The last thing we're going to talk about is what we call z-scores. Z-scores, also known as standard scores. And remember, the word standard means average, so an average score. These are standard scores, or normal scores. And again, the word normal means average as well. Are values that measure the number of standard deviations. And this is important. We're talking about the number of standard deviations above or below the mean. And this only works on a normal curve. It only works for a normal curve. So we know that in a normal curve, the distribution is symmetric and the mean sits here at 0. Because of that, we can measure, based on the standard deviation, how far values are away from that value. If a value falls to the right of the mean, it will have a positive z-score. If a value falls to the left of the mean, it will have a negative z-score. And a z-score is just a transformation. So the value z is always going to be equal to whatever your x is minus the mean of the distribution divided by the standard deviation of the distribution. And we use this to compare normal distributions that have different means and different standard deviations. So here's an example of how we use it. Suppose that there are two students who take college entrance exam. They're taking two different tests, though, the ACT and the SAT. Each test has its own mean and it has its own standard deviation. We're comparing these two students to see who should get a scholarship. The mean of the SAT is equal to 896 and has a standard deviation of 174. The mean of the ACT is 20.6 and it has a standard deviation of 5.2. Two students, Erica and Sam, take these tests. So if we load these up on here, this is 896. And if we can fill it out, and we know that 896, Erica's score is a 1080. So we do this. This is 896 plus, remember, we can add the standard deviations. So plus 174. And I'm going to the right because she scored a 1080. So this is 1070 plus 174 again, and I get 1244. That means that Erica's score is somewhere right here. This is her 1080. Sam took a different test, whose mean is 20.6. And standard deviation of 5.4 is 5.2, so I'll do 20.6 plus 5.2. I get 25.8 plus 5.2, and that's a 31. We can stop there because her score was a 28. So when I look at this, her score is somewhere over here. Now, here's the problem when we try to compare distribution with different means and different standard deviations. If we do them straight off, we can tell by looking at it that they both did better than the mean. So they will both have positive z-scores. The question is, relative to the mean, how much better did they do? We can see that each is one full standard deviation away from the mean. Erica has a little bit above her one standard deviation, where Sam is a lot more above it. We can actually now bring these to the same curve by using this formula here. The z-score formula says that x minus mu divided by sigma x. We'll actually transform it to put it back on a curve that has a mean of 0 and a standard deviation of 1. So I'm going to put it back on this curve where everybody's mean is 0 and standard deviations are 1. And remember, every normal curve has 6 standard deviations underneath it, 3 to the right, 3 to the left. So this curve can be, any normal curve can be transformed back to this curve. And we can measure the number of standard deviations now. So when we go back and look at this, Erica's score was a 1080 minus her mean, which was a 896, divided by our standard deviation is 174. So this is Erica's z-score. So we do this is 1080 minus 896 divided by 174. And I get this equal to 1.0, we're on to 1.06. Sam's z-score is equal to, she scored a 28 minus the mean, which is 20.6, divided by 5.2. And she scored a 1.42. So what that really means is when you're comparing this, you're looking at standard deviations. Erica is 1 full standard deviation and 0.06 standard deviations above her mean. Sam is 1 full standard deviation and 0.42 standard deviations above her mean, which means that we can go back and put them both on this curve now, where here is Erica, here is Sam. And we can see now by comparing them that by comparing the standard deviations, again, this measures standard deviations. I am 1.06 standard deviations above the mean. I am 1.42 standard deviations above the mean. When you compare them like that, you can see that Sam scored better than Erica, so she deserves a scholarship. And so when we look at z-scores, we are measuring standard deviations, nothing else. It is the number of standard deviations above or below the mean. It's above if the z-score is positive. It is below if the z-score is negative.